Hi, in this video, we're going to talk about visualizing our data before we start fitting a logistic regression model. Okay, so before we're going to start building our model, we need to understand our data, and then we need to look at the insights that we can get before we make some critical choices. And visualizations are an excellent way to go about this. I firmly believe that if you can visualize something in data science, you probably should. Nearly 100% of the time. Now, why is it that we're going to visualize our data? Well, first of all, it's to inform us and our stakeholders about what's actually in the data. A lot of times, as a statistician, data scientist, I don't know anything about the data I'm given. I'm just handed data, and my stakeholders have a goal for my project. And I find frequently my stakeholders don't even fully know what's in the data tables before I pull them and show them the results. Also, my data visualizations, if I make good, crisp, clean visualizations, my stakeholders will have more confidence in my project as I go through. In data science, we never make models just to make models. We're doing it for a purpose. We're trying to deliver it for somebody else. And it's important that our stakeholders, the people who receive our models, have faith in what they receive. And if I can set it up so that they believe in me and have confidence from the get-go, I'm in a much better position. I don't ever want to work on a project that doesn't actually get used. So I need to have confidence from my stakeholders every step of the way. Also, our visualizations will tell us how we should, or help guide us on how we'll do our data preparation, also guide us on our feature selection, and can help us figure out what should I do for my model selection for different model structures. All right, so when I kick this off, there's going to be some things I'm going to show. I'm not going to do every possible plot, but there's some I do every single time. All right, so the first one, the most important one, is just going to be what's the distribution of my target variable. Now, this could be for logistic regression, could be for classification, regression, whatever it is. The first plot and the most important one is going to be what does the distribution of my target variable look like? Then after that, I'm going to look at the distribution of my predictors. So I'm going to have plots of the distribution of my categorical data and all plots of the distributions of my numeric data. Now, which plots I use will be up to me, what I'm most comfortable with and what my stakeholders are most comfortable with. Now, the next one, and these are the ones that I'll be leaning on the most as I work through the project, is going to be the one-way plots. So when I say one way, what I'm trying to do, I'm trying to analyze what is the relationship between my target variable and one predictor variable at a time. And so when I say one way, I am borrowing this term from one-way ANOVA. All right, so here are some best practices for visualizations. And these are just what I put in for my visualizations at work. First and foremost, explicit title. Say exactly what it is that they're looking at. Personally, I'll say if it's a bar plot, I'll put bar plot of blah, blah, blah. If it's a box plot, I'll say box plot of this. I'll say beast worm plot, histogram, whatever it is, the very first term. That way, if my stakeholders aren't comfortable with statistics and they don't know how to interpret something, they can at least like Google the title and get an idea of like, oh, it's a histogram. That's what a histogram is that I'm looking at. Now they can try to interpret it. One thing that I do, and I typically put this in the caption on the lower right-hand corner, is I include my data source. So database schema and table name. Also, the date that I pulled the data is a good idea, or possibly source code if I generated it, or the file path to an Excel spreadsheet, or the URL of a website that I scraped the data from or download from. Something I do, I'll put this in the subtitle. I explicitly say what the conclusion is that I want my stakeholders to reach. I've had extraordinary success with this. What I will do, I look at the plot, I reach a conclusion, and I type in the conclusion in a subtitle. What I've had happen in the past is that the stakeholders just get used to seeing it there. They'll look at that, they'll read it. I've literally had stakeholders repeat the words in my plot as if they were the ones who discovered this information. And during the meeting, while I'm presenting it, and they're super excited because they feel like they have like inside knowledge that other people don't have. And so that means that they are on board with my project, they've got confidence, and my project is going to be easier because I have people who are already excited for my work. All right, so here, I always try to do 3 things in my plots. I always try to use geometry, I try to use color, and I try to label things in an explicit manner. Anything that you want someone to like be able to interpret, try to put it in 3 different ways. Simultaneously, color, geometry, and a label. And so for the geometry, try to do something simple like a bar plot. So, that we're just judging the height. Try and keep it simple geometry, or maybe the size of a circle. The size of a circle is like the most advanced thing I would probably show my stakeholders. Also, meaningful colors are really good. If I have something like disease, I could have red for having the disease, green for not having the disease. Also, the stoplight colors of red, yellow, green are really good choices for good or for bad, moderate, and good. I find people pick up on that pretty fast. Now those colors are not colorblind friendly. So if I know that I have a colorblind stakeholder, then I'm going to try and find a palette that will work with it. So I've got a friend of mine, Matthew, who's British, and he is completely colorblind. And I've sat down, I've worked with him to get good colors, that are colorblind friendly to him. Also, your organization might have color palettes that you already have to use, so you can use those. Embrace it. Now, here's another one that a lot of people, when they're first getting started, mess up on, is that they try to put too much information in one plot. Don't try to show too many features at one time. Try to show just the most important things and keep it as simple as possible. Now, when I've got a lot of things going on, a lot of plots to present, or a lot of features, or a lot of things going on, what I'm going to do is I'm going to show the most interesting ones first, and then skip over things. Like, so let's say, and I've had this happen. Let's say I've got 50 predictor variables I'm going to have to use. Well, what I'm going to do? I'm going to show the most interesting feature first, second most interesting, third, and then after a little bit, I'm going to sense that my audience is getting tired of looking at the plots. I skip over the rest. I leave the ones that are least interesting, the least informative, or the plots, the one-way plots that show the least relationship towards the end, and skip over it. And I've had a lot of success doing that. Now, also something that I do, and you'll notice that in my code, I create a data frame that has all the values that I'm going to have on there frequently, especially when I do bar plots. And then what I do at work, I'll save that data frame in my output folder. That way, when someone goes, oh, well, could you give me the actual values here? And so I've got the original data and I have the computed values. And so sometimes people start asking questions. It's very good to have those computed values in your back pocket ready to give them for when you have questions, when they want to look at things more precisely. Also, something that's good to do on the caption is if I filtered or modified or did resampling or anything like that, put that in that caption also. That way, when somebody tries to reproduce your results, if they get a different numbers, you can say, hey, this is why. In the caption, I always try to put in, the information that you would need to reproduce my results. Now, here's an example of a bad setup for a visualization. All right, so here I've got 1, 2, 3, 4, 5, 6, 7 different variables. And you know what? I'm going to try and put all of them into one plot. All right, well, what's going to end up happening is it's going to look like gobbledygook. It's going to be hard to interpret. It's going to be too much stuff. I didn't even make this plot. The data that I'm going to show you really doesn't even lend itself to doing this. All right, so I've got if I was to go through and put this into ggplot, there would be too many things going on. It would be hard to interpret. What you want to do instead is find your most important things and put those in, and have those correspond to multiple aesthetics in there. And so here, this is much better. So I've got, let's say, so I've got, height and weight are the X and Y coordinates. And then a third variable is going to correspond to the color, the group, and the line type. So I've got a line plot going on, and I'm going to have state is going to be the color and the line type on there. So having different line types and correspond to this and match up with the colors is going to make it so that I can use different colors, but also my colorblind colleagues will be able to interpret the plot also. All right, so now I'm just going to prepare my workspace, load the data. So this is default data from the introductory statistics with R package. And so I'm going to do my univariate ones first. All right, so first one, the most important one is the distribution of the target variable. Then I go through my predictor variables. And we're just showing one variable at a time with this. Typically at work, I don't actually show these except for the target variable. Then I get into the one-way plots. All right, so here I'm going to show my categorical data. And you'll notice that here, just to show you how I approach things, is I always create a data frame that I can show people when they start asking questions. And I would always call that data frame m_plot. That's just my convention. All right, so here, this is my target variable. So I can see that 3% of the observations are default, while 97% are not. And you'll notice that I've got height of the bars is my geometry. I've got color to say which one's good, which one's bad. And I've got explicit labeling so that my audience knows immediately the interpretation by percentage, but also what's the count. What I have found is that my subject matter experts, my stakeholders, they know their subject. They know their subject really well. And they actually, in their heads, do a binomial test on their own. They understand that you need a certain number of observations for something to be statistically significant, even though they don't have that precise mathematical description of it. And so they think that way. They understand it, even if they don't have like the vocabulary to tackle it in a precise stat way. And so what I do is set it up this way. So I've got explicit title. It's a bar plot of the default outcome. This is my target variable. If I had something I wanted to say about a conclusion, I would put it in the subtitle right here. You'll notice I have a caption saying where I got my data. And so I find that this is a good system of going. All right, and so now we can go through and start showing some other ones. And so here I've got univariate values. And so here this is student status. Are they a student? Yes or no? Now, so this is my categorical data. Usually I'll present my categorical predictors, the univariate plots, after I present my target variable plot. Then I'll get into my numeric univariate plots. Now there's different ways to go about this. I've got box plots, B-swarm plots, histograms, and density plots. Those are the major ones that I thought of when I was making the script for this video. I personally like histograms and box plots, but most of the time it's not gonna, I might have some problems with that. And so I have to think about what is it that my audience will take in very well. Well, they're probably not going to accept density plots realistically. Box plots, definitely avoid showing your audience box plots. I love box plots, but most people don't. B-swarm plots, these work really well when you have very little data. And when you tell them each point is an individual observation, they tend to get that really quickly. So I like B-swarm plots as long as my data set is small enough. If I can't use a B-swarm plot, frequently I find that stakeholders that have a passing exposure to statistics will accept histograms. Box plots, even though it's in 6th grade curriculum in the state of Florida, box plots just aren't accepted by most people. Most people lock up on it. It's a 5-number summary. It's super easy, but you know what? People don't like them. Avoid displaying them. And density plots, they connect well with histograms, but a lot of times people don't jive with them. I'll use them personally for density estimation, but I wouldn't show it to my stakeholders. So here I've got box plots. Here's a B-swarm plot. Each dot is an individual observation, and you can nicely put a box plot on top of it, which I would not show this to my stakeholders. Now here's a histogram, and I overlaid with the density to make it, that might be something interesting. So here we see definitely 0 inflated on this. Now here's my density estimate, which shows 0 inflation. And so then we can just keep going through all these different plots. And now for my presentation, I'm going to show just one of these for each of the numeric ones. So probably like the histogram would be the one I'm most likely to show. I probably wouldn't have the density on there. Now for my one-way plots, typically I'm going to show my categorical variables. So for logistic regression, I'm going to have binary target or possibly multinomial, but 2 levels. And for categorical predictors, I find that bubble plots are a good idea. So a bubble plot is I have put down a dot, and if I have more counts, it's a bigger dot. If I have fewer counts, it's a smaller dot, or not there at all if it's 0. And so here's my bubble plot. And so we can see, like, visually that 68% of our data, student status was no, and default was no. We can see that 1% of our data, they were students and they did default. So here I can kind of, I can judge what's going on either visually by the size of the dots, or I can go by the labels. And so I've got, 3 things going on. I have geometry for the size of the dots. I have explicit labels, and I have color showing what's good, what's bad. And this is a good way to convey information to people. The bubble plots work best when I have fewer levels. So 2 by 2 is really where I want to be if I'm using bubble plots. All right, so now when I have a categorical target with a numeric predictor, I can split it up. So here's box plots. I use, for this particular purpose, for one-way plots, I prefer box plots. That's internal. If I'm sharing this with other data scientists, other statisticians, this is the one I'm going to use. But when I show it to my stakeholders, this is not what I'm going to use because most people don't like box plots. When I look at the box plots, I want to see the boxes like this, like very different positions. This means that the predictor is not going to be very informative. If the boxes are parallel to each other, if the median lines are splitting horizontally, like splits the other box, that's an indication that's going to be a less informative predictor variable. And I always order my predictors from most informative to least informative. So here's my box plot. Now I can do the same thing with the B-swarm plot. Very nice. And I've got my box plot and the individual data points on there, working that out. I can also split up the distributions. Here, it's harder to really gain as much from this because I need to be able to judge the horizontal positions of the histograms. I could stack them on this, but it does get kind of, it would get squished. So I didn't do that, but that is an option on there. We also do density plots, but it has the same problems as histograms. So typically, I would use, for the purpose of showing, my stakeholders, what I usually do is I do averages. So I do the average of the predictor variable given that the target variable is 0, and the average of the predictor given that the target variable is 1. So I'll have like 2 bars for a logistic regression problem, and both of them are averages depending on the target variable. And then I find that works very well. And so here we have different ones. So here, this is a good example of a predictor variable that I'm probably not going to be able to get much information out of. You can see that the boxes are next to each other. And since they're next to each other, there's not really any way to distinguish. If we look at this one, and we see that we have a large value for the balance, a large value of balance indicates that it's more likely to be a default, while a smaller balance is less likely to be a default just because of where the distribution of the points are. Where here, knowing if it's a large income or a low income, I don't really have any indication of what the default status will be. Now here I've got the B-swarm plots once again, and this is just showing that income really is not going to tell me much about the default status. Now this B-swarm plot does show me that it looks like there's probably two subpopulations involved in the no state, but the data doesn't tell me what that is. I don't know. Here we can also break this up in histograms and do a density plot also. Same trick. I find the box plots are easier for this purpose because I can just judge where are the boxes relative to each other. Now, something we can also do is visualize the correlation and correspondence between predictor variables. And so here, I can use the ggpairs function. This is a really nice one in that this just spits out a bunch of plots for me. I don't have to do a lot of work. I typically don't show this to my stakeholders because when I have a lot of predictor variables, I'm going to have a lot of tiny, small subplots. And it's going to get crowded and it's going to get harder to interpret. Sometimes it'll take me a moment to figure out what's going on. But in one shot, it's nice. I can just spit this out, get a bunch of different plots to look at, and try to figure out which variables to use, which ones to exclude. All right, so homework for this. Go through, take your data, and construct one-way plots of your dependent variable with your independent variables, and just plot it and submit it into web courses. And so just start getting used to the idea of seeing which variables look more informative, which look less informative. That's what you really want to do. In your mind at this point, you want to be able to say, you kind of want a rough ranking of which ones are the most informative predictive variables, which ones are the least, so that when we get down the road and we start doing feature selection, we know to get rid of these and keep the ones that are most informative for our initial pass of feature selection. All right, well, that's all I've got for you. Life is short. Do math.